Okay, and more every moment. Call in user 2. Yes, okay. Okay, great. So if you're here virtually for the Cognitive Crash Dummies course, that's great, because that's where we're all expecting to be. And now if I can get this to work. Okay, great. So I just wanted to give a brief background of me first. So I am currently working for IBM Research, but in my first professional life, I was a mechanical engineer, and I worked at Bell Labs, and I was on the development side, not the research side. But I was one of the systems engineers who were writing, 500-page specifications for data and telecommunication systems. And as a mechanical engineer, all of a sudden I started wondering whether what I was writing was going to be easy for people to learn and use. And so I started taking psychology courses at night because I didn't know anything about people. And what I discovered was that my psychology textbooks were very different than my engineering textbooks. Because in my engineering textbooks, at the end of every chapter, there were problems at the end of the chapter, and in the back of the book, there were answers. And that's because there were methods for getting the right answer, and there was a right answer. There may be a handful of right answers, but it was pretty tractable. But in psychology textbooks, there were no problems at the end of the chapter, and there were things like names and dates and results. And that's because psychology is extremely, or was extremely, empirical. So the names were who did the experiment, the dates was when was the experiment done, and the results were what were the results of the experiment. But it meant at the time there was extremely little theory that would help you predict what would happen in the next experiment. And the thing was that design is all about predicting, because you are predicting that your new design is going to be better than the old design, but for some measure of better. But if psychology couldn't predict, then, and all it could do is measure, then you'd have to build the thing and measure it. And that is indeed what would happen with the human factors people in the 70s when I was at Bell Labs. They would say, you design it, we'll test it. But that was totally too late, because by the time we had something that they could test, there was no time to change it. So I decided this was not a way to build good systems. So I quit my high-paying engineering job, and I went to be a slave, known as a psychology graduate student, and I got a PhD in psychology, where what I have been doing for 30 years is being able to predict what people will do with a design before you build it. And that's what CogTool came out of, and that's what we're here to talk about today. So especially since this is a webinar and I don't see anybody, I see a little window with a bunch of names, I would love to know who's here, where you come from, if you have any, what your professional background is, and if you have any experience with predictive human performance modeling. Now, we do have officially about 20 so people. Looks like there's about a dozen here now. So we don't want to take too terribly much time about this. So make it pretty succinct. So for instance, I would say, I'm Bonnie John. I work at IBM Research. Oh, by the way, I was faculty at Carnegie Mellon for 25 years before I joined IBM, and I've taught this many times in many different types of classes. So I would say I'm Bonnie John. I work for IBM. My professional background is in cognitive psychology and user experience. I do predictive human performance modeling all the time and make tools for it. And I hope to have an exciting workshop that we will have a recording of so that we can share it with other people. So that's sort of detail. Bye. So Shannon, do you want to start?
Okay, I found a good person.
I'm guessing that's Angie. Angie, do you want to start?
Sorry, are you talking to me?
Yeah.
Oh, I was just saying goodbye to my daughter. Sorry, I took my headphones off for a second. Yeah, I'll start. I am Angie Wong. I work as adjunct faculty at the University of Minnesota, and I do contract design work as well. My background is in graphic and interactive design. I have no experience with predictive human performance modeling, and I hope to learn more about that and to learn about a new tool that I could potentially have students use in the classroom.
Okay, great. Looks like Bill does not have any audio device connected according to my participant list. So call in user 2, whoever you are.
So I wonder if that
Okay, how about anybody else?
Hi, can you hear me?
Yep.
Yes?
Okay. So I wonder if I might be calling user 2. I'm not on the list. This is Jen Miller. And oh no, there I am on the list.
Jen, you are on my list. That's okay.
At the top of my list, which I thought was a header. Okay, so I'm Jen Miller.
Okay.
I am a user experience researcher by profession. I'm currently working for U.S. Bank, and I don't have any experience with predictive modeling. So pretty excited.
Okay, great, thanks. Bill, you have gotten a phone icon.
I finally am hooked in.
Hi. So, what's your name? Who do you work for?
Oh, sorry. I'm up. Okay. This is Bill Quee. I work for Thomson Reuters. I work on the UX team doing research. I work for Shannon O'Brien and have a little familiarity with CogTool because she wanted us to get up to speed a little bit on the product, so we were just using it internally a little bit. And that's it.
Okay, great. Let's go to Jay Adams because Channing just joined and doesn't know what we're doing.
Hello, can you guys hear me?
Hi. Yes.
Hi, Jonathan Adams, currently working for a healthcare servicing agency and have done a lot of design work in the past. Do have some exposure to CogTool in the last several weeks. I'm using it for a project that I'm working on and just generally want to get some more information around how to use it effectively.
Great. Okay, Jeremiah, you are on mute. Off mute. Jeremiah? Okay, how about Laura?
Hey, good morning, Bonnie. This is Laura Nesbitt. I am an e-learning consultant and create interactive training and a little bit of work in service design as well. And I'm also one of the board members of UXPA, so it's very nice to meet you and appreciate you being here.
Cool. I was at a UXPA meeting last night in the New York City chapter, and so that was fun. Okay, Lyle Kentrovich.
Good morning. Lyle Kentrovich. I'm currently an independent consultant here in Minnesota. I've been doing usability and user experience work for about 18 years. I've been very active in the UXPA locally and on the international board. A little bit familiar with GOMS and KLM, but I've never actually used them on projects. So I'm really curious to see this kind of new tool and kind of see how it makes those methods more approachable.
It's so much easier. Well, I hope you find it that way. I have gotten feedback that it is so much easier. Okay. Okay, Megan.
Hey everyone, I'm Megan Atala. I work at Century College. My professional and educational background is in technical communication, and I don't have any experience with predictive modeling, so that's why I'm here.
Okay. Renata? Oh, she doesn't have a phone icon. Sorry, Rubina.
I'm here. Yes, this is Renata. I'm here with
Oh, Renata. Hi.
I am physician by background, but not in clinical practice anymore. I did my MS in health informatics from University of Minnesota, and now I'm pursuing my PhD in health informatics, and my topic is to discover elements of a rationally designed electronic health record graphical user interface to facilitate clinical document usage in practice.
Okay.
And I'm interested in using CogTool to do some type of a comparative study between different interfaces.
Ah, yes, okay.
Yeah, and I don't have any experience in predictive modeling.
Okay. Rubina?
Yes.
That was Rubina. Yes, okay. Okay. I have lost track. Other Renata?
Yeah, I'm here.
I don't see an icon.
Oh, hi. No,
are you guys in a room or something? Is that?
We're in a room together,
okay.
yeah.
Got it, okay.
So I'm at Thomson Reuters. I'm in Shannon's team also. So we're doing user research. And I don't have much experience with predictive modeling except for the last couple of weeks taking a look at what CogTool does.
Okay, great. We have a couple of people who don't seem to have phones connected. Channing and Emily, are you guys in the room with?
Emily's here. I'll go. I'm also here with Shannon. I work at Thomson Reuters. I've got a background. My master's is in human factors and ergonomics. So I was in actually physical product development before, and I've moved on to more software research on Shannon's team here.
Okay,
and again,
great.
Very little experience with predictive performance modeling.
Okay, how about Josh Carroll? Is he in the room too?
He is not.
No, he is not, and he doesn't have a phone icon. Okay. Channing?
Channing, yes. I'm a principal user experience designer over at Medtronic. I don't have experience with predictive human performance modeling, but we involve our users in our studies, so I'm interested in how we might use a tool like this to supplement that.
Great. And now we have the mysterious call-in user 2 and call-in user 4. Do people know who you are? Okay, we're going to move on. Okay. I do want to check if everyone has downloaded the materials. I know that Shannon had sent out a link to these so that you get the CogTool code from GitHub at that link, and you get the exercise materials from GitHub at a separate link.
I'm not able to get the program installed.
I'm sorry, you're breaking up. What did you say you were not allowed to get? You couldn't get? You know, I'm a little surprised at that second link. I would have thought that would be training materials. Let me come on. Let me escape. How do I escape? There we go. Hello. Go. Get this. I'm sorry. Was it the training materials, the exercise materials you couldn't get?
No.
Let's see. Yeah, okay, so if you go to CogTool GitHub, and you actually go to the top CogTool one, this is the link. Oh, are you guys seeing my screen? Yes, CogTool course materials. So I probably gave you the wrong thing, and it's the release. So let me apologize for this. I am texting this link to everyone to make sure you have all these materials.
Hi, Bonnie. This is Shannon.
Okay.
That's the link that I did send out to the attendees.
That is, okay, great. I'm sorry I had the wrong one in the slide. Okay, so I did want to say a couple other things about logistics. If you have a question, so in general, I'm going to do some talking about human performance modeling in general. Then I'm going to demo CogTool, and then I'm going to ask you to do some CogTool. While I'm going through some of the slides, if you have any questions at all, put them into the chat window. And then when I get to a good breaking point, I'll go back to the chat window and answer all the questions. I'm going to go off video, because you don't need to see me while I'm lecturing. Much more important to see the slides, and then you won't see when I'm drinking coffee and stuff. And while we do the exercises, again, if you put questions into the chat window, while we do the exercises, I'll just chat back to you unless there's something particular that I need to see, and then we might be able to, change for you to be the presenter so I can see your screen and stuff like that. But we'll get to those logistics when we get to the actual exercise. In general, if you're in a noisy place, be on mute while I'm lecturing, and we will be doing things through the chat rather than through audio, unless there's a particular question that I need more feedback on, and then we'll ask you to go off mute. Does that make sense to everybody? Okay. I guess silence is, it looks like so many people have gone on mute. Okay, great. And I'm going off video. Okay, great. I'm going to make my chat window bigger so I can see when new things come in. Okay, great. And now, back there. Okay. So, I guess I did just give the agenda. I'm just going to give you this little introduction to predictive human performance modeling in general, and then talk particularly about CogTool. Well, we will do hands-on exercises. We're going to take a break because I know, important email comes in and stuff like that sometime after we start the exercises. And then at the end, I'll talk about some of the things that are on the horizon for human performance modeling. Okay, introduction to predictive human performance modeling. So what is it? Basically, it's computer-based computational models that mimic human behavior. And so they're mimicking perception, cognition, and motor actions. There are several what are called computational cognitive architectures that are they're basically a programming language that gives you structure of how the like perception talks to memory. How does memory work? How does it forget things? How does it talk to the motor system? Those things are built into the architecture so that when you write programs in these architectures, you are expressing human knowledge and capabilities in a way that is human-like when it runs. So when the model runs, it then produces a trace and of what it's doing, and you can extract some of the measures that we tend to think about as usability measures from those traces, because it's basically telling you everything a human does. It's telling you everything that a simulated human does. And so if you care about what does it click on, or what keystrokes does it make, or where does its eyes move, you can extract those from the traces. And then you can, if you're a researcher trying to make a new model, you can compare these to human data so that you can validate the model. But if you already have a trusted model, because people have done decades of research, like is under the hood at CogTool, then you just use these traces to get these measures. That's just like you would with a human. So the types of things you can get from these are things like the time that it takes to do a task, because these simulated humans are running in simulated time. And so when it says, oh, it took me 5 minutes, that's similar to what you would expect a human to take. It can get things like the number of errors, and ACTAR, which is the one that's actually under the hood of CogTool, is used a lot by psychologists, and one of their measures is they want to know the blood oxygen level in different parts of the brain. So it's very cool. If you run an ACTAR model, you can actually predict what parts of the brain will light up. So these are things that are much more sophisticated than we're talking about today, but they are all in the realm of human performance modeling. And psychologists use them to test their theories. They want to, come to truth about what are people doing, and we can understand this. We can show that we understand it because we can run these models and get predictions. But we, as either UX designers or software engineers, we want to use human performance models to help us design, to be able to test our design ideas or understand what people are doing. So in interactive system design, there tend to be three different uses. One is to predict human behavior on proposed designs before implementing that design. So that saves a lot of coding if you have 10 different design ideas and you want to see which ones are best or worth pursuing. We can also use human performance models to run inside our systems, and that will take in user data while the user is using it and adapt to that user. So the most successful part of that kind of application is something called cognitive tutoring systems. And hundreds of thousands of children in the United States learn how to do algebra and geometry with a computer system called a cognitive tutoring system, and it has an ideal student. That's one of these type of models that's running all the time next to the human student. And when the human student veers off the path, is demonstrating that they don't know as much as the ideal student would know, then the system adapts to give them more practice in the things that it doesn't know, that they don't know. And that's a very, very successful application of human performance modeling. The other application for human performance modeling in general is to substitute for human participants. And you can do, this is often done in training situations, and the military does this a lot. They will have a war game of 100,000 entities, only 1,000 of which are actually human. But that way you can train large numbers of people on simulated war games in particular. But people use it for other types of training as well. It just happens to be funded a lot by the military. So a lot of the academic examples of this actually are military. So we are talking about today predicting human behavior on a proposed design before implementing that design. I call this cognitive crash dummies. And the reason I call this cognitive crash dummies is just like an automotive crash dummy, where you can test the design of the car before you do all the tooling to make a real car. You're finding out how it's going to kill and maim people. You use a cognitive crash dummy to test your user interface before you go to the trouble of building it. And the other reason I use cognitive crash dummies is I have discovered as an academic that if you call a class human performance modeling for UI design, you get 7 people signing up. If you call it cognitive crash dummies, you get 41 people signing up. So I tend to use cognitive crash dummies because it is more attractive. So just very briefly, some of the history behind this, and it's important to know this only to understand that this is not new, okay? There was a book called The Psychology of Human-Computer Interaction. This book actually coined the name of the field, human-computer interaction, and it presented modeling frameworks for predictive models to evaluate and guide design. And I forgot which person, but one of the people said that they were familiar with GOMS and Keystroke-Level model. These are the names of these frameworks that Card, Moran, and Newell put forth in this book, The Psychology of Human-Computer Interaction. They called them engineering models of human performance, and we'll see why in a second. They talked about engineering models, and I call them cognitive crash dummies, because they can make a priori quantitative predictions of human performance. And the a priori means they're based on previous research in human performance, not on getting measurements of your particular system, because that's what design is all about. You haven't built the system yet, so you can't wait to get measurements on it. That was the problem I had back in the 70s, where the human factors people were saying, you design it, we'll test it. Testing goes out the window when your schedules shrink. So you base your predictions on previous research in human performance, and you want also quantitative predictions. Things like, how much time is this going to take? How many errors is it going to take? How long is it going to take to recover from error? These sorts of things are what are in the broader realm of engineering models or cognitive crash dummies. And the reason you need something quantitative is when you're at the design table with the whole team and they're trying to decide what to do, having discussions about this, there's always going to be trade-off discussions. I was a systems engineer. I was the person writing the specifications. And when I sat around the table with human factors people in this system, the electrical engineers and mechanical engineers and the software engineers, and we were agreeing on requirements, at the time in the 70s, the human factors people would say, well, we like interface A better than interface B. And then invariably, some software engineer would say, oh, that's going to take so much more coding that I'm sure we're going to, we're going to take up more space, basically. And electrical engineers are saying, oh, you mean I'm going to have to put another memory chip in there? And then the mechanical engineers are saying, oh, wait a second, that's actually going to make the box bigger. Okay, and so the engineers can say, this is how much more money it's going to cost. And so the UI people also have to have something quantitative to say, yes, but look how much more money it's going to save in productivity or in training time, and so that you can all talk about dollars and cents, because just about any number you can have gets reduced into dollars and cents pragmatically in discussions. And so I found it a lot more powerful to be able to say people are going to be 50% more productive, and now I can multiply that through by how many people we're going to need, and it's especially good for internal costs for systems that are used internally for your productivity, or if you're selling things to the enterprise and people are trying to make their staffing more productive. It's much better than saying, it's my opinion that interface A is better than interface B. And you'll see some more of that in practice later. The other thing about cognitive crash dummies, or these engineering models, is that they have to be learnable and usable by system designers. Not every company can have a team of PhDs in cognitive psychology if these tools required so much understanding of psychology that only PhDs in cognitive psychology could use them. So these have to be learnable and usable by system designers, either UX or system engineers. And they have to cover total tasks. In psychology, you see a lot of models. I have a model of typing, or I have a model of reading, or I have a model of pointing, or I have a model of visual search. And they don't all work together. But when someone comes up to your interface, if they sit down with their laptop on their lap, or if they come up to your iPhone or whatever, they're going to do it all. They're going to be visually searching. They're going to be reading. They're going to be tapping. They're going to be typing. And so your models can't be stovepiped into these little silos that don't talk to each other. You have to have models that do it all. And so the cognitive crash dummy will cover everything. When I present those first three things to a room full of psychologists, I see them all shaking their heads. That's important. That's impossible. That's impossible. That's impossible. But this last point is that they don't have to be the truth to the 15th decimal point. They have to be usefully approximate. So if every model in any discipline, especially in engineering, has a particular precision and accuracy, and the engineers who use it in engineering know what the the scope of the model, the accuracy of the model. They know when to trust the model, and they know when the model isn't speaking to the particular thing they need. So in particular, CogTool has been shown over and over to be within 10% of the truth. So if CogTool says that two interfaces, interface A and interface B, are within 10% of each other, you say, well, CogTool can't distinguish between these two. But if CogTool says that one of them is 50% faster than another one, and you can say, oh, you know, prior research has shown that this one really is going to be faster. Now, if it matters to your particular situation that you have better than 10%, then you're going to have to use another technique, like usually empirical studies. Now, realize that when you're doing empirical studies with people, those also have a particular accuracy. There always has noise in the system, and so it's not really any different knowing what your accuracy of model is than doing empirical studies. So models can be usefully approximate. So HCI has been predicting the efficiency of interactive systems for 30 years. And this is the Keystroke-Level model that I mentioned earlier, and some of you are familiar with, which is a member of the GOMS family of models. What you do to get a prediction of efficiency or time on task is you decide what tasks are important to you, to your target users, and you make a set of tasks called a suite of benchmark tasks, and you have a specification of your proposed system. And then you express the procedure for accomplishing this task that they're going to do over and over again in terms of a small number of operators. What are they going to type? Where are they going to point with the mouse or with a finger, now that we have a lot of touch screens? Are they going to have to home hands between devices? Like, are they going to have to move from the keyboard to the mouse? Are they going to ever have to wait for the system response time? And those are things that you can posit. Okay, you know, you're the designer. You know when people are going to have to tap or point or hit keystrokes. And you can play what if with the system response time. Well, what if it was totally instantaneous? Well, what if it takes 10 seconds to get this information back from the database? So you can define those things. And then there's this black box operator called a mental operator. And Cardmoran and Knoll did a lot of research to say, how usefully approximate would it be if we just said that all unobservable actions, which to them meant eye movements, so visual search, thinking about what to do next, remembering a command name, verifying what's on the screen, those were not observable in their log files. Okay? And they squished all those into what they called a mental operator. And then they found where those pauses in their mostly click logs showed up in many, 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 many tasks. And from that, they could determine how long this approximate mental operator should be and approximately where they show up. And people are pretty consistent in where they think. They tend to think before they submit a form. They're looking over it to make sure that it's okay. They tend to think before they hit a button that's going to create a command. You know, so these kind of heuristics of where to place these these mental operators is what Cardmoran and Knoll gave us in the Keystroke-Level model. So you make these little series of K, P, H, R's, and M's. Each one has an empirically established execution time. How fast do people point? That's Fitz's law, if you've heard of that. How fast do they keystroke? Depends on how fast they type, but you can play what if with that. You'd make this little series, you add them all up, and the output is the time that it would take a skilled user to perform these benchmark tasks on your design ideas, on your proposed systems. So this is looking at error-free behavior. It is what I talk about as the EPA mileage estimate of your interface. So just like when you get the EPA mileage on cars, they always say your mileage may vary. They're saying there that this is an approximate answer, but it is still really useful in buying a car. I mean, if you're looking at a car, one version is, you know, it's the EPA estimate is 31 miles per gallon, the other one is 32, you say, oh, they're about the same. But when you look at that big truck that's 12 miles per gallon, you say, oh, those are really different. And so this is like that. This is under ideal conditions, error-free, but it's helping you see what would be the potential for efficiency in the real world. Now, simple as this sounds, it has been perceived as too hard to learn and use by designers and developers. Now, some people who have had human-computer interaction classes, as I believe I tortured Shannon with this when she was at Carnegie Mellon. She was there pre-CogTool, and a lot of people ran screaming from this. They said, okay, I have to do this homework. I will do it. I will get whatever grade I got, and I will never do this again. This was a problem that I perceived back in 2000. I've been teaching it already for many, many years. And so we went around fixing that. So now I'm going to tell you how we fixed that problem and a tool that's much, much easier to use than the Keystroke-Level model. So I would normally pause and ask here if there's any questions about this predictive human performance modeling in general. I don't see that anyone has typed anything into the chat yet. But if anyone wants to go off mute and ask a question, this would be a fine time to do that. Okay, nothing? Okay, great. Okay, we'll move on to CogTool. If I can get back into the right. Okay, so our goal is to make it easier to construct human behavior models and reduce the cost of learning and creating valid models so that people might actually use it, because I perceive this as a very useful tool, but not if nobody can use it, right? I think about this as a toe-in-the-door philosophy. So my goal was first to make the very simplest models, which are the Keystroke-Level models, really, really easy. And our hope is that that will get some people interested in doing more powerful but complex models, and they might move on to using other models, like Dave Kiris has some GOMS tools and things like that. But I also have this secret hope that as we go along, we should be able to gradually expand the power of the tool and put more and more powerful human models under the hood without sacrificing usability of the tool. So that was kind of my goal for a releasable tool that actually goes out to practitioners. And also, we want to expand the scope of what Quadman and Newell's models could predict. They were designed for office work, so we're going to move to domains beyond office work, and eventually we'll get to measures besides task execution time of skilled users. Now, I am a good user-centered design person, so I did all the user-centered design techniques that I taught at Carnegie Mellon on CogTool to create CogTool. The first thing I did was error analysis of what people did wrong when they were doing Keystroke-Level models. So I found that people forgot whole parts of benchmark tasks. In particular, there's a lot of kind of bookkeeping, like where are the hands? And people would forget that they couldn't have the hands on the keyboard and the mouse at the same time. So they would forget these homing operators, which are about half a second apiece. So that made a difference. Novices found it very, very hard to apply Quadman and Newell heuristics for placing those mental operators. And they usually included too many mental operators. Now that's interesting because if you notice, those top two reasons actually counteract each other. So they would forget whole parts, but they would have too many mental operators. So often people got kind of the right numeric answer, close to the right numeric answer for the really wrong reason, which made me very sad as a teacher, but seeing a really good opportunity as a system designer or tool designer. And if you wanted to use Fick's law, which is a mathematical relationship between the distance that someone has to move their hand and the size of the target that they're moving to, it gives you a prediction of time to do that movement. If you wanted to use that and you had to measure things, how far away is this button from that button? Very tedious, very error-prone. So CogTool is solving these problems and a bunch of other problems that are found by providing this as a prototyping environment. You might think of it more as a storyboarding environment. And then it automatically produces a valid cognitive model, a valid Keystroke-Level model from a demonstration of the task on that storyboard that you've made. So what CogTool does is it builds in all the psychology under the hood. You do not have to know how to do a Keystroke-Level model the way Cardman and Newell presented it. You don't have to think about mental operators. CogTool does all that for you and then presents it to you as well as the answers. And we'll see how that happens. So this is a big screenshot of CogTool where, just as an overview, your first step is you mock up your design in a storyboard. And there's many different ways to do that. You demonstrate your tasks, the steps that a user would have to go through on that storyboard to do a particular task. And then you hit a compute button that's at the bottom of the demonstration window. And it gives you a spreadsheet, basically, of how long it would take to do that task on that system. So in this little spreadsheet, you see that we have 3 tasks. The rows are tasks, and the columns are different interfaces. And this is an analysis of a couple of different bibliophile websites where you can share and talk about the books that you've been reading. One is called Book Tagger, and the other one's Library Thing. And you can see that these things take different times according to CogTool, and sometimes substantially different, like logging in and adding a book to your collection. So now, wait a second, I'm going to show you the little bit more. Because this is a human performance model, and remember I said there's this engine under the hood, in this case in CogTool it's Actar, and it's producing a trace. We parse that trace and make a visualization for you of what the model is doing. And so in this picture here, you're seeing the different things that a user would have to do for Book Tagger and for Library Thing. The top line in gray for each one is what frame are they on, what screen are the people seeing. The purple is what are their eyes doing, and this is based on a relatively sophisticated model of eye movements and perception. The middle gray line is what are they thinking, and some of them are really tiny thoughts like move my eye, but these big thinks, as you can see, think 7, think 20, those are the Cardman and Newell mental operators that CogTool has placed for you automatically. Okay. And then in red are what the hands are doing. In this case, moving the cursor and clicking the mouse, typing some things in. Okay. And then you can look at these, compare these timelines and see what are the different interfaces doing, and you can extract design recommendations. Now, there was a Kai paper about this in 2011 that you might want to look at and give a couple more examples of extracting design recommendations from these timeline visualization. So we're going back to the first step of ways to build prototypes. So there are typically, most people use 3 different ways to build a prototype. You can import screenshots of existing systems. So this is very, very useful for benchmarking current systems. Like if you're making version N+1 and you already have a version N of your system. so you're going to benchmark how long does it take people to do things on the current system, and you can do that by importing screenshots. And then you're going to propose a new one and see if it's better. Okay. You can also use this for competitive analysis of your competitors. Okay, because they have an existing product, you can gain access to that product and buy one or use their website and take screenshots there so that you will have a benchmark to be able to say our new design is 40% faster than our competitor's design. Okay, this is the way that we'll do the hands-on exercise because we're going to compare a couple of different products that already exist. You can instead sketch design ideas and import the sketches. So you literally can make sketches on paper or on a whiteboard and take pictures of them, okay? Or you can use Photoshop or whatever you like to do your own prototypes in. As long as they make pictures, CogTool will import many, many different types of pictures, okay? And you can also just use CogTool itself as a wireframing tool. It puts up a canvas and you can make wireframes. I'll show you that how to do that in a second too. So I have a couple of examples of these. Oh, I forgot. Okay. There's actually a couple more. There's 2 more ways. Okay. There's an import from HTML command under File. So you can point it at a URL and it will go and take pictures of it and get all the buttons on it. Now, it is definitely not perfect, but it sometimes can give you a useful starting point. It's getting less and less perfect because when we did it back in, 2006, there was a lot of very plain HTML on the web. Now almost everything has JavaScript, and it doesn't do much with JavaScript. So I'm just telling you about it because if the thing you're doing is kind of vanilla HTML, even with CSS, it can do a good job. But it is definitely not perfect, but it can be fast. And we have done some research of automatically creating models from running systems. This is definitely a research project, and it's pretty brittle, but you can read about it in a Kai paper as well. So here's an example of sketching design ideas. These people literally sketched on paper. You can see what one of the frames looks like on the right-hand side. They were doing some sort of a a landmark logging program on a handheld device where you could go in and say, get information about museums, and you could put up a restaurant that you liked, and it would put it on the map. And they literally sketched what it would look like, and they imported all these sketches, and you can see that their storyboard is actually quite complicated on the upper left. Those are all the different screens that a person would see and all the different paths they could get to from one screen to another. And this is an example of using it as a blank canvas. I have 2 pictures on the top. This was the interface that we were trying to mimic that was written up at a paper, and we could just do that directly in CogTool with its wireframing capability, and you can see the interface looks extremely similar. Okay. Here's an import of the old CogTool website. I just told it to go to that website, keep going, and capture an image for each page, and it grabbed a lovely storyboard of that. But that was when the CogTool website was old and very vanilla. Had some CSS, but no JavaScript. Okay. And then this is an example of Amanda's system that this thing on the left-hand side is all you had to do. All you had to tell it was you had to point it at what application you wanted to analyze and where you wanted to put the results. And then you said create a new task. You gave it a name. You told it, you hit a button that said start demonstrating. It would open up the application. You did your task. You came back and said stop. And it made models for you. Okay. So this again is a time to stop and go to the chat window for questions. Okay. Okay, CogTool among expert users tend to be used for novices. From Rubina. Oh, that was privately. Sorry, guys, I'm going to read these out loud. Okay, so CogTool, CogTool originally started with Keystroke-Level model, and so that's only for skilled people. Now, we have continued research on that, and I will show you things later in a version called CogTool Explorer. And that has a model of information foraging under the hood, if you've heard about that, which information foraging is a model of how do people search for information. And so we have a PhD thesis that the references to in your notes by Liang-Li Chao at Carnegie Mellon, where he built CogTool Explorer and showed that it could detect tasks that were easy for novices, hard for novices. There's a Chi paper or two on it. It has not been validated as extensively in real-world tasks as Keystroke-Level model has. It's still in the research stage, but all the code is there in every CogTool that you download. It's in the release that you have. You can play with it, and I'll show you how later. And all the code for it is there. So if you're adventurous, you can play with it. If you want to contribute to the CogTool project, which is an open source project, by trying to validate it, talk to me later. If you have data of novice users, that would be fabulous to try to figure out how to move that research forward. But at the moment, there is an existing system. The code is all there. It works to some extent on the data, certainly on the task we gave it, but it needs a lot more validation, in my mind, to be a trustworthy tool for everyone. Okay. And then with importing shots of existing systems, we need to watch the sizing of the screen images. Yes, that's an extremely good point. It doesn't matter how big the screens are, as long as they are all the same. So what it's going to be doing with how long it takes to point from one thing to another, it is going to take the distance of where it's going to know where the hands are. It's going to remember that. And so when you come onto a screen, it's going to know where the hand is, and it's going to look around and find the button you have to go to next. And it's going to take from your storyboard how far the distance is and how big the target is. Now, Fitt's law is actually the ratio of the size and the distance. So it doesn't matter if they're really small or really big, because it's going to do the ratio anyway, but it does matter if it changes from screen to screen. So they all have to be the same size, but they don't have to be any particular size. You don't have to say, oh, this is an iPhone, therefore the image has to be, 2.5 inches by 4.5 inches. You don't have to do that. Next question. Have you tried this with importing existing code for mobile devices? We have experimented with some of that. I had a summer student last summer who tried to use some of the logging devices on mobile devices. We've had some problems getting complete imports from that. So I have not found a logging program or application that gives me as much information as CogTool needs. So if anybody wants to talk about, that may know some things like that, that would be terrific. And certainly we have done things with mobile web, and that has the same issue as the as the regular web. If it's JavaScript, we just can't do it. Okay. So the sizing of widgets matters as well. That's the next question. Again, it doesn't matter. It matters that you get them relative to each other. And relative to each other, how far away are they of widgets? But not, it doesn't matter if you use big pictures or little pictures. Okay? Going back to users, are the experts considered as system design or users with routine cognitive skills? Okay. You are modeling a person who is skilled with this interface. So you as the system designer know how you expect skilled people to do the tasks. And so that's what you demonstrate. But the model you're getting out of it is a model of a skilled person, a skilled end user using that interface. Now, this is really good because it's not, when you do these demonstrations I talked about, it's not watching you and timing you. So you don't have to be a skilled user of the device. It's going to create a model of a skilled user even if you really don't know how to use this device and you're constantly going back and looking it up in the manual. And this is great for competitive analysis because you don't have to know, you don't have to be a skilled person in your competitor's product. If you have your competitor's product in their manual, you can do the first step, go look up in the manual what the next thing is, come back and do the second step, look up in the manual what the next thing is, and you're still going to get a skilled model at the end of an end user. You can start your demo, go off and get coffee, and come back. It's not timing you. It's just taking the actions that you do and building a valid cognitive model for a skilled end user. That answering your question? Boy, this is hard without the real-time interaction of people. Okay, have we gone to quiescence on the on that? Okay, looks good. Let's move on to actually using CogTool. Okay, I'm going to ask again. I can't get an answer because we're not talking to each other, but I'm hoping how everyone has it, and I do have the wrong link there. I'm sorry for the releasing. Oh, I know why I have the wrong link. Because I changed the GitHub after I sent the slides, after I made the slides. Right. Okay. It is that GitHub. If you go to GitHub CogTool, you will see a portion of it that's called course materials. Okay. All right. So what I'm going to do is I'm going to explain an interface and a task. And then I'm going to get you started building a storyboard. And I'm going to go through actually the whole storyboard and up through the predictions of one interface. And there's two more interfaces for you guys to do to as an exercise. And so I'll start. You can follow along with your CogTool, and then you'll be doing the next two. But before we get to that, I do want to show you some of the resources that you have to help you when you're doing this. You should have downloaded the CogTool user guide. It is a PDF. Actually, you have version 1.2, I believe, not 1.0, it's shown here. And I have bookmarked it all. So if you show the bookmarks, it has all the chapter headings and things, so it's a little easier to navigate. I've also enabled comments on it, so you can annotate it yourself and get to your comments. And search works. Okay, this is really kind of a reference manual. This is not a get up quick and this is the reference manual, not the quick start guide. So it's complete. It has a lot of stuff in there, and please make use of it when you're searching. You can search it. You can use these chapter headings. Okay. You can get the sources from GitHub. We recently put it up there. I left Carnegie Mellon about 3 years ago, and just less than a month ago, I finally ran out of my bank account at CMU, and they took down the old CogTool website. So we have moved everything over to GitHub for the CogTool code. You can get both the source code, you can get the documentation sources, you can get examples, and you can get releases. I find that GitHub kind of hides this release tab. I could not find that myself for the longest time, so I'm pointing it out to you. If you want to see the latest release, you go to the regular CogTool GitHub, and that's where the releases tab is. And then once you get to the releases tab, you'll see that there are latest releases, and then there's some pre-releases in this more exploratory researchy software that you can also play with. There used to be, up until just a couple of weeks ago, a website at Carnegie Mellon, and some of the pointers that you'll get if you Google CogTool still point to Carnegie Mellon, but that is broken or down, and it now directs you to a WordPress blog. As you can see here, there's not much on there yet. What I am in the process of doing, as I saved all the content, all the questions people have asked over the years, I'm going to start putting them up, one at a time, probably, of things that people have asked how to do, and there are examples of how to model particular things that are going to come up there. If you, I do monitor this. This comes in my email. If you have a question, I think there's a contact me. Just put it as you can put it as a comment on anything, and I'll get it, and then we'll surface it up to a question that other people will be able to find as well. So hopefully you'll be, and all the publications are up at the moment, so they're all, you can look at all the papers that are there. Okay. So now I'm going to tell you about the interfaces and the tasks. And you have all of this in the PDF file called Collaborative Shopping _ Task Instructions that you hopefully have already downloaded. And that gives you all the instructions of how to do the task in 3 different interfaces. So we did contextual inquiry 1 year for some class of roommates shopping for a couch. And what we saw in the field was that these roommates barely ever saw each other because their schedules were so different. And so when they would kind of take turns, not formal turns, but whenever anybody had some time, they would go look it on Craigslist and find something that they thought was nice and immediately send it out to the other folks. They would do it actually by Gmail at this point, and they'd say, here's a link, I like this one because it's cheap or whatever. And so we use that as our field work as inspiration for a task that you might have to do often if you were doing collaborative shopping with people who are not, sitting next to you. Okay, so we're taking this task of sharing a link and a comment. The one we observed in the field was using Gmail to do that, and we're going to compare it to two other interfaces. One called Google Notebook, which used to be a really nice little plugin for browsers that they don't support anymore. And we're also, in a different field work, we saw a group of people set up a wiki, a free wiki. This particular one is serviced by something called Wet Paint. And that's how a bunch of people searched for an apartment together when they were on different coasts. They would just use wikis all the time. So we thought we would compare those three, and that's the exercise we'll do now. Okay. So we're going to make some assumptions. One is that we assume that when somebody gets this information, they're going to follow the link anyway. So it doesn't matter if the link is some unreadable URL or a page title, something that a human could comprehend. Okay, it would be fine either way as long as it's a hot link that they'll just click on. Okay. We're going to assume that everything has 0 system response time unless the instructions specifically say that something takes a while to load. We're going to assume that the task starts at the Craigslist listing of a couch that this person wants to share. And we're also going to assume that any necessary sharing has already been set up. So there's a Google Mail group, there's Google Notebook sharing, and all the wiki permissions, they're already set up, because that's something you do once for this task. And what we're modeling here is how long does it take to share a link with a comment. Because you really want this to be fast, otherwise you're going to lose that couch. Things disappear off our Craigslist pretty quickly. So you want this to be fast. And then we have one more little assumption that the user's hand is going to start on the mouse. Okay, so we're going to do the Google Notebook method first. And here's the start screen. So in each one of these pages, the format of it is what screen they're looking at. Underneath the picture is the action that they take, and there's big red arrows that show you where on the screen they're supposed to take the action. So in this case, the person to use Google Notebook, they have to highlight something on the page, and we're going to say to do this task, we're going to highlight the text of the post by triple clicking on it. So that's the way this particular browser works. You triple click on a line like that, you get the whole line highlighted. Then once it's highlighted, it goes into this screen. With the Google Notebook plugin, you get this little plus sign that looks like a button, okay? And the user has to click on the plus sign that has appeared because she highlighted something on the screen. Then something else shows up that says note this, and you click on that. You click on note this. That has now appeared in the place of the plus sign. And this takes a little while for Google Notebook to come up. And so that after you click the note this, it takes about 1.25 seconds. And what happens is on the next screen is this little box appears at the bottom right of the screen. The cursor is already in the comment field. The link is already there. And all the user has to do is type, I like the color and price, and click on the button, Save Now. This is the end of the task. This is the screen that they're going to be at, but we're going to say that the person actually looks at the Save Now button, which has changed to Save, to make sure that it actually happens. Now, the way Google Notebook works is you have sharing set up. It notifies the other people that you've shared it with that there's a new entry in this notebook, and they can go see it. Now, they can go do their task, which would be to look at it and decide whether they liked it or not. But this is the end of this task. So this just took a couple of steps. So before we start talking about how to get it into CogTool, does anybody have any questions about the task? Okay, I'm really glad that as you have a question, you type it into the chat window, because this is the way this webinar is working. So that's great. Okay. So what we're going to start doing now is creating CogTool models. And your course notes have these things that they tell you a little bit about the different windows. You can be looking at your course notes. I'm going to change over to CogTool itself so that you can see what I'm doing. Okay, so now I have to escape. And I'm not going to use course notes. I'm going to use actual CogTool. So this should be the version that you have, 1.2.2. Okay. When you open it, because you have not done anything before, if you haven't done anything before, you won't see this Open Recent button. That only appears when you have done things before. So I'm going to create a new project. Okay, and now it says because each project must have at least one design, please enter the name of the initial design. And this is the name of the interface that we are creating. So this is the Google Notebook. So I entered that in. And what sort of input devices are we going to use in this design? Well, this is a task on a laptop. So we have a keyboard, we have a mouse. You can see that we can have touchscreens and we can have microphones. We can actually model things with auditory, so you can talk to your system and it can talk back to you, because we have the ability to model both hearing and speaking, and your devices would then be a microphone and a speaker. But in this case, we only have keyboard and mouse. So I say, okay. So it has created for me this project window, which is representing what I'm going to have columns that represent the designs. So eventually I'm going to have 3 columns. And I'm going to have rows that represent the tasks. And the task we're going to do first is share a link and comment. And you just double click on it, type in the name of your task. Just about everything in CogTool is click on it once to select it, and then there's all sorts of things you can do with the menus with it, or click on it twice to edit it. So I did the click on twice, and I do that a lot because I'm a skilled user of CogTool. But say you wanted to change the name of this task. You could click on it once, that selects it, and then you can come up to the edit menu and you get all these different things that you can do with tasks. I can cut it, copy it, paste it, delete it, duplicate it, and the manual tells you all the things like what's the difference between copy and duplicate. They really do have different functionality. If I wanted to rename it, I can do that way, and it puts me in that same editing mode that you get at if you just triple click it. So in general, click once to select. I said triple click, I meant double click. Click twice to edit. So again, if I wanted to change the name of the task, I would just double click it. But for the this tutorial, I'll try to remember to select and use the menus because you can see it better than if I'm mysteriously double clicking. So CogTool opened the project window for me, but it also opened a what's called a design window. And this is where I'm going to create my storyboard. It has started one frame for me, but really what I want to do here is import frames from a folder of images that I had collected previously. So I go up to the Modify menu because I'm modifying this design. And the very first thing, because almost everybody does this first, is import images as new frames. So I select that, and it gives me a file picker. And now I have to find it. I think it's in my GitHub folder. Oh, CogTool GitHub, that looks good. Training, CogTool course, CogTool exercise materials, not answers, images, collaborative shopping images. And you should have this folder. And inside, there are 3 folders. I have the Gmail images, the Google Notebook images, and the wet paint images. So I'm trying to import images as frames. So I click on the folder that has my images and say choose. And it gives me a bunch of frames to work with. As you can see, these are the same images that are in your task instructions. Now, I have several frames. These frames have pretty pictures, but they're not active. They're just background images. So in each one of these, I'm going to have to go in and put the widgets that someone would need to use to do this task. So I remember a single click to select it. Blue means selection, and I want to edit my frame. This brings a window up where I'm going to place these widgets. So if we go back to the task instructions, normally I would ask someone in the class to tell me what we did with the first thing, but this is not interactive as easily, so I will go back to this. So it says, highlight the title of this post. And it says I'm going to do it by triple clicking. But first I have to decide, well, what widget is this? So here's the title of the post. Right now, this is just a screenshot. So this is just pixels. This is nothing. On my side here, I have a bunch of different types of widgets. You can roll over the widgets and get an explanation of them just on hover. Oh, I'm sorry. I'm using the research version, which doesn't matter. I just may have a little more things in my menus than you do, so I'm going to go turn that off. I will tell you what that means later. Okay. Now I should be showing you exactly what you see. So, and how did I know that? Because I had a little thing down here that said research. Okay. So we have these different tools over here. So I have a button, I have a link, I have a checkbox, a radio button, I have a text box, I have text itself, I have pull-down menus, context menus, pull-down lists, and scrolling lists. And I also have something called a non-interactive widget. So I have to ask myself at this point, what kind of widget is this? Because this is where CogTool gets its magic. Remember I said that people had a really hard time placing those mental operators? Well, CogTool associates the mental operators with the different types of widgets. And so it's important that you think about what widgets people are actually using here. And don't make everything just a button. Because if you make everything a button, you will not have a valid cognitive model. So you have to say, well, what is this? And there is a lovely appendix, lovely if I do say so myself since I wrote it, in the user manual, in the user guide. I think it's appendix B, maybe C, that tells you all the widgets and what it should, and which widget you use when. And I should probably open that to show you. Okay, great. Let me find appendix. Okay. Oh my goodness. Appendix A, appendix B, types of widgets and when to use them. So it tells you examples, shows you examples of buttons, it tells you when to use these, and it goes on for many pages. The problem was people stopped after the first page. I actually leave this open when I model still, and I go and say, "Oh, is this the right kind of widget?" And this has quite the extensive explanation of why you would use one widget over another. So I suggest that you have that open as you're starting to use CogTool and look through it. And you say, well, this is the most important decision you make. What kind of widgets are this? So this, it doesn't look like a button. It doesn't act like a button. It's got to be something else. Yeah, it's obviously not a checkbox. It's obviously not a radio button. It's obviously not a link. Is it a text box? Well, the text box is usually, something that like where I'm going to type a URL or where I'm going to edit something. So it's not really a text box. Is it text? Yeah, text. Something I can highlight, something I can copy. It's words that I can get at. So I'm going to say this is text. I select the text tool, and I just drag over that piece of screen. Now, when you do that, it puts you into an editing mode because many times you're going to put a name into this text. But since we're using a background image that'll shine through and show you what the text is, we're not going to use that editing part. So we're just going to click outside of it. And you see it is now over this. You could be approximate. You don't have to worry whether you get this pixel perfect because the mathematics under the hood is going to wash out little differences in pixels. It's not going to matter very much. Right now, we chose the default of these kind of hotspots that we're putting on here, the color to be orange, because when we started, orange was not a very popular color in interfaces. I have noticed in the last couple of years that orange has become a very popular color, and so you might want something else. And so you can do that up in Set Frames Widget Layer Color. And so then you get a color picker and you can make it magenta instead. Okay, when you're selected, it's of course the opposite color, but you can see that you can change the color if all of a sudden you discover that your company is using orange. Then you might not want the default. The other thing I'll show you is that undo works very well, and in fact we have a multi-level undo. So I can undo that set widget color, and I go back to orange. I can undo the little move widget I did. It moves down a little bit. I can undo the new widget, and then I can redo it again. So I want to give you some confidence that if you make a mistake or you place something where you didn't expect to, undo works. we put a lot of effort into making undo work, and I believe undo even works beyond the last time you saved. Like I said, we put a lot of programming effort to make undo work because we knew we would have people who would be trying this out and doing things where they change their mind a lot. So now we have our first widget. It is a text widget, and on this screen, the only thing someone's going to need to do is operate with this text widget. So this screen or frame is finished. Now when you come back here, I'm going to make this a little bigger so you can see it better. Don't make it too big because then I have all the chat windows and stuff are on top of it, so I can't see it. Okay. So you can see here that we now have this orange highlighted part, and as I roll over that, my cursor changes to tell me that I have a something active there. And it does tell me what it is. It tells me it's a text widget. It also tells me that it's called widget 1. Now, widget 1 is fine. It's a unique name that CogTool will be happy with. But if I come back to this, I won't know what that is. So I'm going to go back, highlight it, and change the name of the widget. I'm going to call it the title of the Craigslist page. So you can put anything here that would help you remember later what this is. And you could probably type better than I do and not make spelling mistakes. So now when I roll over it, I see that it is the title of the Craigslist page and it is typed text. And now what I'm going to do is, so the frames show you what the user sees, what your simulated user will see. What I'm going to do next is representing what the simulated user will do. So you roll over it until your cursor changes. You press down your mouse key and drag out to what will the user see next when they operate on this widget. And in this case, they're going to see the second image where that label is highlighted. And so you can drag to whichever image is, whichever frame is the right one. You can see that it turns to dark gray to show you that you're on it. And you release. Over here on the right, you'll see that we have created what's called a transition. And it has defaulted to a mouse transition and clicking the left button. But actually, we wanted to triple click the left button, not click it. So I can pull this down and see that CogTool can easily simulate double clicking, triple clicking, pressing, releasing, and hovering. So in this case, we were supposed to triple click, so I select the triple click, and it's now giving me all the information about this transition. It's a transition, it's a mouse action. It's going to left triple click. And it doesn't need any modifier keys like Shift or Control or Alt, but if you needed those, you could check those. The source is that widget that I named. The destination is this frame, okay? And down here, I have something for wait for system response time. If there were a long system response time here, I would enter in the number of seconds. But we had said that we were assuming that unless otherwise noted, this was an instantaneous thing. So we're not going to put any seconds in here now. So we're going to go to the second one. The second frame, I double click on that to bring this up so I can edit it. And in this frame, my title is highlighted and this new thing has appeared. My task instructions said I'm going to have to click this thing. And then the question is, what kind of thing is it? And so you go back to the, yeah, that's what I want to do, preview. I look here, in my preview, is it a menu? No, it's not a menu. Is it a sub-menu? It doesn't look like a menu. It's not text this time. It's not a radio button. It's not a checkbox. It's not a link. It doesn't look like a link. I mean, these are not links, okay? You know, kind of looks like a button. So I might say it looks like a button. Okay, so it could be a button that appears dynamically on the screen. Yeah, okay. That's good. And, you know, it kind of looks like a button to me. So I'm going to go and make it a button. So I select the button tool. It was actually selected by default. And I draw my little widget on top of it. And I'll, this time, remember to give it a name. I'll call it the plus button. Okay. Now, our instructions say that when you click this, it goes to another screen. So I come back to my design window to represent what the user does. So I'm going to roll over it until I get to the my cursor changes, and yes, there's my plus button. That's useful when you have a lot of different things. This one we only have one, but when you have a lot of things close together and you want to make sure that you put it on the right one, that helps. And it's going to go to the next screen. And again, this screen, we just keep doing this. We've got another button. And note this button. You don't have to, you can call this anything you want. I just, by force of habit, always put the type of thing in it. And then when the user clicks on that, they go to this screen where this window is popping up. Now, this is the place where in the instructions, the task instructions that you have in your PDF, it said it took 1.25 seconds for this next screen to pop up with this little Google Notebook. So in this case, this transition, after you left click on the Note This button, you have to wait for the system response for 1.25 seconds. And I can put a label on this, wait for Google Notebook to appear. And then it gets a little trickier. Here's this screen. I'm going to make this a little bigger. By the way, you can actually go outside this range. You can make it like 300. I think you can make it all the way up to 500 just by typing in here. Now I can do 400. That's really big. So the cursor is already ready to type. So actually, I don't have to do anything. Now this is a place where I have, through many years of user feedback, there seem to be two types of users of CogTool in the world. People who say, when I'm typing on the keyboard. And people who say, when I'm typing into a text box. And they think about that differently. I mean, they can't, I have a very, very, very hard time convincing one type to think like the other type. So CogTool lets you do two things at this point when you're talking about a typing part of the task. You can either say, this screen comes up and the cursor is all ready. All I have to do is type and not bother putting a widget there. Or you can say there is a widget text box there. There is a widget called a text box. And put your text box. There's nothing in the text box, but I'll still give it a name. Okay, so it's the comment text box. And you'll see in a second the two ways that you could use this depending on which way you think. But on this screen, you're going to have to do two things. The instruction page in the PDF file that you have for called task instructions says on this page, you're going to type in that comment, I like the color and price, and you're going to click a button, Save Now. So here's the Save Now button. So I need to make a widget on top of that as well. But these are the two things that you're going to do on the screen. So now we have placed all the widgets that a skilled person would need to do this task on the screen. And you can see here, I now have, let me make this a little bigger. I now have two orange things, that text box and the button. Now the way I think about it that people type on keyboards. And if the cursor's already there, then all I have to do is start typing. If I were the person, all I would have to do is start typing. If the keyboard weren't, if the cursor weren't in the text box, I would have to move my mouse and click on the text box. But in this case, the task instructions say that the Google Notebook designers have put this cursor right there already. So the way I would say it is that you drag from this keyboard, that is a device associated with this frame, and in this case, you're not going to be going to the next screen because you still have to hit that Save button. You're going to be going to the same screen. This is called a self-transition, where you take an action, but it doesn't move you off the screen. And you can see that this is now gray, so it knows that it's going to do this self-transition. And when you do a keyboard transition, it brings up this thing and says, well, what are you going to type? I like the color and price, period. Now you can do things like control keys and alt keys and tabs and all that sort of stuff just by clicking on these buttons. But in this case, all I had to do was type this. When you do, you don't need to do Shift for just regular capitals. But if you have something that, you know, is like a Shift, Control, Alt, or whatever, then you would need the Shift key. But if you're just doing text, you can just type it in without the Shift. And I say, okay, I don't have any system response time. This just works with 0 system response time. Okay, there's my transition. And it makes this little transition between the keyboard and the same frame. But now I'm supposed to click the Save button. So I do my transition from Save. It defaults for a button from the mouse, left click. That's perfect. That's exactly what I wanted. And I'm at the last screen. Again, the task instruction said this is the last screen, but our user is very conservative and decides to make sure that they look at the fact that that Save button changed, it changed to Save. But right now, that is a non-interactive thing. You can't do anything with it except look at it because it's grayed out, right? So for that, we're going to use something called a non-interactive widget. We're going to need to give CogTool a target of where its eyes are going to look, but it is non-interactive. So I drag a non-interactive widget over that. So this is saved. Non-interactive. Okay. So we have our full storyboard for this task on this interface. Yeah, I'm going to stop and go to the chat window. And the chat window was, how do you suggest timing the system wait if they exist? Okay, often what people do is they'll take some sort of screen capture. I'm on a Mac, so I tend to use ScreenFlow. I like that a lot. But any sort of screen capture, and I just use the timing on that. So basically, I take a video of what I'm doing and take the timing off of that. Now, it could be that you've got a really good internet day or a really bad internet day. So you might want to do it a couple times if you really care about the internet speed, or you can do all three if you're doing different internet-based applications on the same day. If you can do them all within an hour or something, then you're probably getting about the same speed. So what you're trying to do is compare apples to apples, and so you don't want to do one on an Ethernet hardwired and one on the Wi-Fi. You want to try to keep them equal. The other trick you can do is you can say, after you have measured them and put them in, you can say, what if everything was blindingly fast? And go and remove them all, and then compare the interfaces again. To say, how dependent are my results of which interface is better? How dependent are those results on the internet speed? And so you can play that game with it as well. But basically, I just video myself or screen capture myself doing it and use it that way. Where did you enter the time delay again? Okay, that is associated with what the user does. And so, because it's what the user does and what the system does in response to what the user does. So things that have to do with what the user does are on these transitions. So you can select these arrows, and down at the bottom of the arrow is how long do you have to wait for, down at the bottom of the properties pane on the side is how long do you have to wait for the system to respond to that action. Okay, and then basically with this model variant of DOMs, we are focusing on the physical operators only. Am I right? No, you are not right, because CogTool is going to place the mental operators for you, and that's the next step. So that's a great lead-in to the next step. So I'm just going to go there. Okay, so now I'm back at my project window. And I have this design. I double-click on that, you see the storyboard. And I have this tab, share a link and comment. Now I have to tell CogTool how to do this task on this design. As you saw in some of the examples, some of these storyboards get really complicated. There's lots and lots of things you could do on any one screen because there'd be lots and lots of tasks you could do. So in the case we're doing here, there's really almost only one path, so it seems a little silly to have to tell CogTool what to do. But even in this simple task, when it gets to the screen where it has to do two things, it won't know which one to do first. So we have to tell it that. So I click at the juncture of doing this task on this interface. That's the cell in this spreadsheet that doesn't have anything in it yet. I can select it and go up to the edit menu and say edit script. So I'm making a script of actions from this, or I could double click it. And the first thing it asks me to do is pick a start screen. So as you saw from some of the examples, again, if you have, well, I've had some where there's like 300 frames in here, okay? We give you a physical layout, but sometimes when you have 300 frames, it's a little hard to find the one you want. We also give you an alphabetical list, okay? In this case, it's easy to just say, I'm going to do Google, I'm going to select this one. I can then say, which is my mouse hand. That's because my lead developer was left-handed, and so he wanted to be able to pick between right and left. And where does the hand start? Now, we had assumed that the mouse was going to start on the mouse. So I select those things, and then I say start demonstrating. Okay. So then it shows me, this is the screen you said you started on. And in this column, it's going to start recording those actions that you do. So you roll over your widgets here. You can either do the things that are on the screen, or you can do the keyboard, which is down at the bottom of every screen. And when I roll over it, it says, okay, this was the title of the Craigslist, and I have defined on it that I can left triple click. When I click on it, it asks me, do I want to perform this left triple click, or do I want to just look at it or add some self-transitions? Most of the time, you're going to do the thing that you defined. And so over here, what it is recording is that in white is what you tell it to do, and in yellow is the things that it's going to do for you. So you don't have to bookkeep, like where is the hand, where does the mouse have to move, when does the mouse have to move. CogTool is doing that for you based on the widgets that you put in. CogTool always starts like at the upper right at the very beginning, excuse me, upper left at the very, very beginning of a task. And so it says, I know that the person, the simulated human, is going to have to move the mouse to this widget. And then the simulated human will left triple click on that widget. And then that gets me to the next screen, which it has shown. Task instructions say the next thing I'm going to do is click on this widget. Now, because the only thing you can do on that is left click, and it's not something funky like triple clicks or shift clicks or control clicks or anything, it's just clicking. That's the most common action. We have made CogTool default to, if I click on this, instead of getting that menu, it just puts it there. Okay, and why it, there's a bug. It should not change the menu, column size that I very carefully set. Okay, so at this point, the thing that I did was I showed it to left click on the plus button. And what CogTool has done, based on prior research, it says this is one of the times that people stop to think about clicking on a button. So they have to think about it, and then they have to move their mouse to that button because it was, you know, kind of in the center of the title before. And they left click on the button, and that moves it to the next screen. They have the next button, and sure enough, it says, oh, they're going to think about that also. Again, this is set by prior research. And they left click, they move the mouse and left click on the button. But here, because we had defined that this took some time, it also puts in wait for Google Notebook to appear. That was the label we put in for this system response time. And you have to wait for 1.25 seconds. And you get to the next screen. Now, we're in this screen. We have to go over to the side here to find what we did. This is the tricky one because this is the one where we had two actions. And I only defined one way. That's okay. We'll do the way that I told you to do it, which is in the keyboard. I'm now going to go down and click on the keyboard. And it has a transition defined on it to perform the typing of I like the color and price on the keyboard. So I select that. It puts in that I have to put my hands from the mouse to the keyboard, and I have to type I like the color and price, and notice it knows about the shift key there, so it knows there's an extra keystroke to get that capital I. Okay. And if this sentence, if a touch typist would do this sentence all on the left hand, it would be smart enough to know that you don't have to home to the keyboard, that you can keep your hand on the mouse, your right hand on the mouse, because we have observed very skilled people doing that. If they can type all on the right hand, and all the characters happen to be on the right hand, then they leave their hand on the mouse. It's amazing. But CogTool's smart enough to know what's typed on the right hand and the left hand. It has a model of skilled typing under the hood, and so it does this home keyboard appropriately. So we have to type the thing first, and then we click the Save button. And again, prior research says people tend to pause before they do a Save button, so they're going to stop and think. They've got to get their hand back over to the mouse. They've got to move the mouse to the Save button and left click on the mouse. And now we're at the last screen. Now remember, our instructions said that we had a conservative user who was going to look at that Save button to make sure that it changed from Save Now to Save. And we had put this widget in here, this non-interactive widget. So we can't do anything. We can't click on it because it says that there's no defined transitions. You can't do anything on a non-interactive widget. But I can look at it. So I can either click on it and select Look, or there's some things down here where you can add these unobservable, like I can say, Look at Widget, and then click the widget. And it puts in a look at. Now what it is what CogTool is assuming is if you are deliberately looking at something to get information, then you're going to think about that information. Now I want to warn you to don't think too hard about these look ats. CogTool already puts the eye movements in for normal use, like for clicking on a button. You don't have to say, look at the button, then click on it. CogTool already does that. It's only when you're looking at something very deliberately because you have to get this information, and it's not part of the kind of the normal way of using something. So you would have very rarely would you use these look ats. I just put it as an example so that I could exhort you not to use them very often. So now we have finished the script, and I'm going to hit the Compute button, which gives me a time that I can see up here, and also fills it in the Google Notebook, in the project window. It says this is going to take about 18 seconds, and the range is 16 to 19. I'm going to show you that in a second, what that means. So let me go over to the chat window. Okay. So now I'm sure that question about we're focusing on the physical operators only, you now see that you are focusing on the physical operators, but the model has the mental operators in there as well. Those are the think operators. My understanding so far is that the system designer needs to do a task analysis before using CogTool, and this purely depends on analyst judgment. No, I would not put it this way. I would say that a designer, be they a system designer or a UX designer, has to know how somebody's going to use the design. We did contextual inquiry with lots of UI designers, and they typically do storyboards. And when they present their storyboards to people, they show them a picture and they say, and then the user would click on this button, and then they show the next picture. And it's only that level of task analysis you need. You basically just need to know how to use the system. It would be the same thing as being able to write an instruction manual or just demoing it to someone, showing your grandmother how to use it. It's not anything like a cognitive task analysis or it's kind of the normal way that people who design interfaces show people how their interfaces work. So I don't think about it as a really separate step. If you know how to use the interface, it's just recording that in the CogTool storyboard. So if you want to follow up on that, put something else in the chat, or maybe whoever put that up, Rubina, do you want to say something more about that task analysis notion? Can I involve users when doing task analysis? So Boy, can you go on voice and ask this more voice way? Because I don't quite understand what you mean.
Can you hear me now?
Yes, I can hear you now, Rubina. Thanks.
Yes, Bonnie, like I was thinking, like since I will be working with, like my users would be clinicians,
yeah.
right? If I'm looking at a task which clinicians routinely perform, so is it a better idea that while I'm doing a task analysis or before doing a task analysis, I sit down with users and listen to them or observe them how they are doing the task or how they are performing the task, and then I, write it on paper or make a diagram what I observed?
Yes. So when they have an existing system, it's great to go into the field and find out what people really do and find out what their tasks are and how they do those tasks. That is absolutely a fabulous thing to do, because if you're just sitting at your desk imagining what tasks they're doing, then you will have the wrong set of tasks, most likely. And this is exactly what we did. Remember, I said we did contextual inquiry on collaborative shopping, and we found that what the people did is that they wanted to find something on Craigslist, share it with their friends, with their roommates, and add a comment. And so we got the kind of the high-level task of sharing a link and comment from field work. This is important to them. They do this a lot. And then we did find one way they actually did it, which is the Gmail one, which we haven't gotten to yet, but and we use that as a comparison because this is what they do now. And then we are imagining other ways they could do it. In this case, it's with two other existing systems, a wiki and Google Notebook. But in your case, you may be designing new interfaces and comparing how they do things now to the way they would do it on your new interface.
Okay. Yeah, makes sense.
Okay,
yeah.
Great. Thanks.
Thank
you. Hey, Bonnie.
Yeah?
This is Jonathan. What I did was I actually did a WebEx recording of the user on the existing system. And then I was able to play back the recording and extract the necessary information to build the model. Just as another example of how to work with existing systems.
Yeah, exactly. That's similar to me doing things with ScreenFlow, because you have the images there, and they're all the same size. You can just grab them, right? And you have what they did, and that's a really efficient way. People do that a lot when there are existing systems. Okay. So there were a couple of other, I missed how to get into the script step list view. Can you repeat that step? Yes, I can. So this demonstration, this script of, think of it as the steps people have to do this task that I've listed in a row on the project window on this interface. Remember, as you get further along, you'll have different interfaces, different columns, and you may have more tasks. So when you think of it as, how do I do this task on this interface, you select that juncture of this task on this interface, and then you can hit the edit menu to say edit the script, and that brings up this window. And if it's blank in there, it's going to bring you up a window with the first screen, but no steps in it yet. If there's something in it already, it's going to bring up what you've already done. Okay. And then, can you go over that initial step to go from the design mode to the script step? I think that's the same question, right? Okay. If I'm missing a step, okay, go ahead. Yep.
Lost track of the window that yours is called Untitled Project 1. I must have closed it. Can I recover that window?
Yes, you can. This is a little complicated. So in the user guide, it's powerful, but it is complicated. So the user guide actually has a whole section on this because it. Come on, window. Tell me. Oh, Windows too many. Sorry, I'll show it to you. I'll show it to you. You go to the window menu, okay, and the first thing at the top is what project you're working on. Now, you may be working on several projects at a time, and so it'll tell you the name of the project. Right now, oh my goodness, it looks like I haven't saved it. So I can select that, and maybe I should save project. Okay. Let's put this on my desktop. Okay, so that's how you get that. And you can go and it'll list all the projects you have. Now that I have a saved one, it'll list it by name, and I can get to the project window or the script window. Those are the ones that are open. If I select the design by clicking on it, then I can edit the design. That brings up the window there. And there is a section in the user manual about how this window management works. Most of the time, you have a whole bunch of windows open. It doesn't slow anything down, and you use the Macs have keyboard shortcuts to get between windows. I don't know if PCs do. Just haven't used a PC in so long. Okay. How do you get the range? Okay, yes, I was going to show you that. This is a new feature that was asked for by previous users. You go to CogTool Preferences, and there's a couple of things. So you can set your minimum frame width. This is particularly useful when you're trying to do things like mock up your iPhone. You want something smaller than the default pixels. When you import a whole bunch of images, you can tell it how many you want per row. So if you're importing 300 images, you probably don't want 3 per row. You probably want 20 per row. And then you can also say the number of decimal places to be displayed in the results. CogTool, remember, is plus or minus 10%. Okay, it's within that accuracy. By default, the ACTAR model under the hood actually gives you milliseconds. And so you can get 3 decimal places. And we used to have just 3 decimal places. But we found that managers really like all those numbers. And they shouldn't, because they think that something that's 13.335 is faster than something that's 13.421. Okay, so to get them to not grab those numbers, we have changed the number. You can change the number of decimal points. I tend to use 1 or 0. Okay, and then you can display the range again for this problem that managers wanted to say that 2 things that were within 10% of each other were really different. They really wanted to grab onto that. We can display the range or not. And so in this case, I have displayed the range, and this says that this task is going to take about 18 seconds, but it could be anywhere from 16 to 19. I can also say, don't display the range. And when I say, okay, I get 17.7 because I changed the decimal points as well. But I like to keep that range in there. Okay. So that's how you get that. And it rounds mathematically up or down depending on what the 3 decimal points are. Okay. Are there certain limit to number of screenshots that can be incorporated into CogTool? No, there are not. There's no arbitrary limit. I can say if you have really high resolution images, you can slow things down a lot. So we tend to reduce the size of the images, and if you have, I've literally done things with hundreds of images. Sometimes I have to break them into separate projects, but it does fine with it. It may slow things down a little Someone said my computation comes to 17.7. Well, so does mine. The difference would be, remember we were hand drawing how big these widgets are. So your widgets may be a tiny bit different size than my widget. That will make a difference maybe in the second or third decimal point. Typically, it's nowhere near in the, plus or minus 10%. It really is, it's still an approximate model, and those little differences that you may see between my models and yours are probably because we have slightly different sizes in how we drew the widgets. My time is slightly different. I think I can know how to do exactly what I said. Once I change the preferences, it's only okay. Good. Thanks. Okay. So now you guys are going to do the next one. I cannot understand you. Now I can again. Oh, I think my super duper microphone went into my script. I'm sorry. Okay. All right. So now I'm going to go back to the slides. Okay. And, oh, come on. Make this. Come on, slide. I want to be able to, I'm sorry, I'm having problems manipulating these little windows for the screen thing, for the WebEx on top. Okay. So now we've done this model, and you are going to do the next one. Oops. Okay. I want you to do the next one, but I don't have that open, so I should open it. Open task instruction. Okay. Task instructions. Okay, so you are now going to do the Gmail. So this starts on page 7. And because it was quite a while ago, I'm going to show you how to get those frames back in there again, start a new design, but then you should use these task instructions to make a new model. So this was a long time ago. So you're going to be creating a new design. So you're in the project window. You hit the create menu. You're going to create a new design. Because this one is Gmail. So we're going to call it Gmail. Yes, it has a keyboard and mouse. It's defaulted to that because our previous design was that. And so you don't have to keep it if you were going to compare like a mobile site to a desktop site. But here we are going to use the keyboard and mouse. So now you say OK, and it makes a new column. And this column is selected because of some of the toolkit we use. The selection is showed by a little dot for the things on the top. Unfortunately, they never fixed that. So now we're going to edit the design. It gives you this design window, and you may or may not remember from quite a while ago that to import these images in Modify, Import Images as New Frames, and this time you select the Gmail images. It does remember what folder you were in, so if you were following along with Google Notebook, it should be at the right place to get those Gmail images. You say choose, and now you have all those images that are in your instruction manual, or excuse me, task instructions, and now you're going to do all the things that it says to do. Okay. So what we're going to do here is take a little break. You guys, can take a break, whatever you need to. Come back and start working on this. I'm going to take a very short break, but I will be back to answer questions that come in to the chat window. I still have a problem. I cannot get my script window to appear. Okay. Oh, I'm sorry. Laura said that privately. I will answer this question privately. Okay. But everybody else, you can take a little break or you can start working, and we will, I'll be back shortly. Click on the URL to highlight it. Type Control-C to copy the highlighted URL. Click on the Gmail tab to switch to Gmail. After 5.5 seconds, the next page appears on the screen. And you get to O2. You click on Compose Mail. Get to O3. And at this point, the cursor is already blinking in the to field. Type ROO to get the roommates group to appear. See next image. Note, when the R is typed, a list of contacts starting with R appears. When the first O is typed, a list of contacts starting with RO appears. When the second O is typed, the list of contacts starting with ROO appears. It contains only roommates group as seen in the next image. Okay, great. So that's what we're going to walk through now in the CogTool itself. So that was 3. Okay. So the cursor is already in this. And this brings up that point that I said before, that some people really want there to be a text box because they type into the text box, and some people are happy to say they type into the keyboard. And I had mentioned that, but then I didn't detail it. So here's another opportunity to do that. So some people they really want to put this text box in here. And that's fine. And so now in screen 3, our PDF says, the cursor is already blinking the to field, type ROO to get the roommates group to appear. See next image, which is 04. Okay. So either you don't need any widget here because it's just typing and the cursor is already in the right place, or you can put this text box in. So when I go to 3, the transition, according to the task instructions, is just type ROO. Now, if it were me, I like to say it types on the keyboard, so I would make my transition here from the keyboard. And I would just say type ROO. No response time, because it didn't say that. Or you can say, for the people who think about it as I'm typing into a text box, you can have this text box widget there, and you can draw your transition from the text box. Now, it defaults to a mouse transition, but the cursor's already there. You don't have to left-click in it. So we can change the type of the transition to keyboard. Brings up that keyboard box, and I type ROO and say OK. These are totally equivalent transitions. So when you do your demonstration, they will give you exactly the same prediction. It is totally up to you about how you think about it. Do you think about it as the person types on the keyboard, or do you think about it as they type into a text box? So you can do it either way. If the cursor wasn't already there, then you would need that mouse transition to click in it. And so you would draw a self-transition and it would default to the mouse left click. But our instructions say we don't need that because the designers put it in the right spot, the cursor in the right spot. So we're just going to delete that one. I just wanted to show you, to mention that. Okay, so did anyone have more questions? Was that, Shannon, you said your group had some discussion on that transition. Was that, what was your discussion?
Yeah, hello, can you hear me?
Yeah, I can hear you.
Okay. Yeah, that was exactly like we were, Renata figured out the keyboard transition because we were thinking, is it a look in the box or is it just the keyboard, and then how does it transition to that other page? Because I had initially gone to keyboard to the Gmail 3 image itself rather than it transitioning to Gmail 04 image.
Ah, okay, well, let's look at that next screen in our, oh, I'm in the wrong thing. When you type ROO, this is what shows up. This, it's too small to see, isn't it? Let me show you in CogTool. Not that window. Even closer. So when you type ROO, this starts auto-completing, or it gives you an example of, not example, it's what it thinks that it has remembered, these groups that start with OOO, and it only has one. And so the typing actually gets you this new screen. Okay, so there's some more discussion in the thing. Okay, if the roux results in a list of items that the user must select, you need to add a frame to contain the generated list, then the select at the bottom transition to the next screen. Yes, that is exactly how you would do it if you wanted to show that. For demonstration purposes here in the tutorial, I made it a little easier by having the person type a little more. But if you wanted to just say, well, what happened when they typed R? Well, they got, 15 things and they can't find what they want. Well, if they type RO, well, then they'd have, 4 things and they might be able to find it. So you could do any of those. It would just depend on what you would like to demonstrate in your tasks. Now, what people tend to do is, one, they would go out into the field and see what people normally do. So if their users predominantly only type one thing, then they would do an analysis with people only typing one thing. But you would keep that for any interface that you used, that you were trying to analyze. Or so you would then make an assumption about the users, that you would explicitly say, users only type one character before selecting from a menu. Or some users type everything out. They never select from the menu. And so you would make your assumptions about your users to be able to fairly compare different interfaces that might come across that same preference for users. Okay. What if they hit enter when roommates appears? Okay, if they hit enter when roommates appears, you could demonstrate that. What you would do is, instead of having a transition of ROO, well, you could do it 2 ways. If they really knew, if you were assuming, if you knew that the only thing was going to be roommates, then your transition could be ROO enter. If you were assuming that she had a look at roommates to make sure it was right, then you would have a non-interactive widget on this roommate and put that look at in there and then hit enter. Then have the typing transition from this screen to the next one that would be enter. Okay? Okay. Okay, did we want to go to the next screen? Okay, so 3 to 5, someone had asked for. Okay, so what's happening on 4? Click the roommates group. Okay, so that means that I'm going to click this. Now, what is this thing? Right? Is it a button? Is it a tab? Is it text? My opinion is that it is either a, okay, it would probably, I would say it would be a button. So I would make a button over this. Oh, and one of the things to notice, you make your buttons as big as the actual active area. So sometimes things are designed so that like only the text is really active, and you can't actually click outside of the text. If that's the way your system is designed, that's how big you have to make your button. So I would say that's a button, and then you just have a left click on that button to get to email 5. Now you might want to consider whether that is my appendix B. Come on. What happened to appendix? Appendix B. Can I click on you? Yes, I can click on you. So it's definitely not a link or a checkbox or a radio button or a text box. It's not really text because you're not trying to select text or edit it. It's not a menu header. It might be a context menu. Yeah. The problem with a context menu is what the problem is. Yeah, there's an explanation about why the context menu isn't quite the right thing. That is too long. I'm going to have to write that up and put it in the WordPress blog. And I promise I will do that. Okay. How would the results differ if the roommates widget were defined as a button versus a text box? Okay. So one of the things is also in here, one of these appendices, yes, steps placed automatically by CogTool. You can actually go into, this is a prose version of what the code is underneath about how we decide to put think steps. Cartwright and Newell their data, pretty much said that people think before they issue commands, and they tend not to think before they select arguments. And that's kind of a rule of thumb. So in general, most of the time, buttons issue commands. And so CogTool places a think step before clicking a button. Most of the time, when you are clicking on text, you are selecting an argument that you're then going to do something with. You're going to, hit the Control-C to copy it, or you're going to do something else with it. And so most of the time, when you're clicking on text, when you're doing something with text, you're selecting an argument. And so CogTool will not place a mental operator there. So if you use text instead of a button, then you would get a mental operator, think operator, before the button, but you would not get it before the text. But it's not really text. Text is stuff that's, like in a document or in a field. So this thing is an active thing. So kind of think about that. Is this thing active or is this thing not so active? That's how you would think about it. Okay. If it's a list of names, it would be more like a drop-down list. Oh, what a great idea. Yes, I like it being a drop-down list. In fact, I like it better being a drop-down list. And I think if you were to open the answers, you would find that it is actually a drop-down list. Thank you for saying that. So I'm going to actually remove this and make it a drop-down list. I had forgotten about that one. Which one is this? Is that this one? No, it's this one. Come on, roll. That's a pull-down. Yes. Yes, I love it. Okay, and this is the roommate. And that's great, because that is actually the right thing. And what happens there when we do a little demo with a drop-down list, come on, hello. Oh, you know, that's right. I wasn't actually in the right window. Come on. Go away. Let me bring back. Huh. I have never had this bug before. Why will it not let me do something? Let me do that one. I am on a pull-down list header. Ah. Yeah, okay, so this is the problem. Remember I said it was a longer discussion about why it wasn't a context menu. It's the same discussion about why it isn't a header. Let me see if I can. I really apologize. I hate to say this, but I'm going to look at the answers. I am going to open up the answers, which I told you not to look at. And Gmail, somebody else was almost done and wanted to know if this was approximately the right time. And yes, your time was approximately the right time. Here is my 4. And I called it a list box. Because it's just, you're just selecting from a list. That is a better one. And if we went to the thing here and went and looked at it, it says, when there is a visible list of items from which one or more can be selected, that does not have to be pulled down or popped up with a separate action, because it appeared itself. That's when you use list box item. And here's some examples of list box items, and this is also a list box item. We have this list that appeared all by itself with our typing. It appeared this list, and we're selecting one thing from that list. It is a list box item. Thank you. Since you're typing and just arrow down or click, it's kind of like a drop down or a combo box or a list box. If we look at the others, like the pull down list, which is also called a drop down, you use a pull down list anytime a list drops down in response to a click or tap on the displayed item. Okay, so these types of things, they have one thing that's displayed, like this. You have to click on it or tab through it to get the thing to come down. And then you either click on it or tab on it, and then it goes back up to the top. That's what we're calling a pull-down list. And so this one doesn't do that because it doesn't, you don't have to do anything to pull it down other than, it kind of appears with your typing. And when you select the thing, it doesn't like stick it up at the top and leave you on that widget. Okay, and then the other possibility was, oh, combo box. So that's, yeah, this pull down is like a combo box that this guy you can't type into. So were we together, or had I a visual of each one of you, I would be able to see if I just totally confused you all. And I can't see that. This is an interesting experiment in how to teach this. So, not confused. Yay, someone's not confused. Thank you. Okay. Can we look at the keyboard functions on Gmail? Okay. Look at the keyboard functions on Gmail 5. Yes. You can look at the keyboard functions on Gmail 5. Okay, so here's my answer tab. And you have these answers. And not only do you have these answers, I'm going to show you no, wrong place. We can also open the answers. What you have in your materials that I sent, I have repeated all the task instructions, and in yellow, I have highlighted what this means for making your CogTool model. So you can actually go through everything we do with Google Notebook, and I say, you know, we use a text widget and why we're using a text widget and what transition we're using. Went through all of that with CogTool, with the CogTool model of Google Notebook. And again, we have it for Gmail. I have it for each one of these. Everything in yellow tells you why we did what we did in the model. So here, for instance, if you wanted to go later and see why we did Gmail 5 the way we did, it says click in the subject field. That's what a user would have to do. Type couch I found. Click in the main message area to put the cursor in that area. Okay, so the reason we have to do this is click in the subject field, because the way Gmail works is that it doesn't put the cursor in the field. It doesn't have a cursor anywhere in this particular field. It already filled in the 2, but this version of Gmail, which was a few years ago, didn't put the cursor anywhere. So we actually have to have a text box widget and click in it before you can type in it. Okay? And then we're going to have another text box widget that's the size of the whole message area, because when we want to type the message, we're going to click in there. And you can really click anywhere. You don't have to click way up in this little corner. You can click anywhere to put the cursor there. And so the transitions then are, you have a left-click self-transition from the subject text box widget, because you're going to click there, but nothing's going to change on the screen. You have a typing self-transition from the keyboard or from the text widget. As I said, you could do it both ways. And you can put in couch I found. And then you have a left-click transition from the message text box to the next window, because we decided to use that next window. So what I wanted to show you was that all the answers with an explanation are in this PDF, so you can go in and look at that anytime you want. Okay. Yes. Okay, so we're still talking, so I went through Gmail 5. How do you do a self-transition? Okay. And I go back to this. Okay, so here I am in Gmail 4. Let's get to Gmail 5, and I'll make it really quickly. I have two text boxes, one in the subject line and one in the big screen. I'm not going to bother naming them right now. Well, maybe it'd be easier. Message field. Subject field. Can't spell. Okay. And here, the first thing, so you're always, the transitions are what the user has to do. So they have to, first thing they have to do is click. I'll make this bigger. First thing they have to do is click. So you roll your mouse over it until you get your crosshair and you have the subject field, and make a self-transition. You just drag off the widget just a little bit. This whole thing will turn gray, so that's your signal to know that it understands you're making a self-transition, and you let go. And so it's saying from this widget, you can still go to this frame. It's going to stick them around the edge of the frame. Then you say, what is it? I found a couch, or couch I found. Couch I found. That's your self-transition on the keyboard. And then you click in the main message field and drag off to the next screen. Okay? So the folks who were, does the size of the text box being selected matter? The size of every widget does matter because it's going to be calculating how far a person has to move their mouse and how big the target is. Because when the targets are really big, they can be sloppier and it takes less time. The targets are really small, and then they have to be more careful, so it takes a little longer. If the targets are really far away, then it takes longer. If the targets are very close, it takes shorter. And that's a formula called Fitts law that's been around since 1950 that very robustly predicts how long it takes to move the horizontal motion of either a mouse or your finger if you're tapping. So you do make the widgets the size of the actual active area. So this guy is really big because somebody could click anywhere in this box. They don't have to be precise. They can just go anywhere in there and click. This one is smaller because you have to be precise. If you click in the wrong place, you don't get into the subject line. Okay? So typically at this point, I point people to the answer key because I think all the answers are in there. And if you find something that somehow the answers are not in there, you can send email or we can post things on that WordPress site, CogTool.org, I think. No, CogTool.com. Somebody bought CogTool.org. And normally I would go back to talk about the future of cognitive modeling. Some of the things we've used it for, which is really valuable for you guys, and then maybe some of the forward-looking research stuff. Since I do not see a million questions showing up in the chat, I would tend to do that. Are there any other questions that you want to answer about actually doing this? Oh, not sure I'm getting computer time of 0. Okay, Lyle, do you have a little time after this that I could work with you on that? Okay, good. We'll do that. It's probably because here's my guess. You have created a lovely design that has all your widgets, your frames, widgets, and transitions, but you did not go demonstrate the script. That is my guess. And your project window does not look like that. Your project window looks like this. It has a nothing in your Gmail and you have to double-click on it and go in, tell it where to start, and then do your steps. If that's not it, let me know. Oh, you would have gotten it. We'll talk about that later. Sorry, I'm going to take that one offline. Okay. What I'd like to do, oh, I did want to show, I'm sorry, I did want to show you a little bit about using this visualization. This is important. So when I get to your script window, there is a button up here that says Show Visualization. And that gives you your timeline. This is a standard overview plus detail interactive technique. So you can size this window by moving this thing up here. You can drag to see different pieces of it. You get a lot more detail down here, like this is the left hand pressing this particular key and that right hand pressing that particular key. And if you are interested in what's actually happening under the button ActR, if you press on any of these, it will give you the actual trace. Okay, so that's if you want to look at that. But what's more fun is being able to compare two designs. So now this, I'm looking at the answer key. So we have three. We have Google Notebook, and let's compare it to Gmail. And now I have the Google Notebook on the top and the Gmail on the bottom. And let's say I spread, oops, that's not what I want to do. I'm going to spread them all out totally. And we can see that Google Notebook takes about half the time of Gmail. And that's where you can start saying, why are these different? And you can go in and say, well, what's this pattern? This looks like typing. You get to know this stuff. And this is in that paper at CHI 2011, I think, on how do you get design ideas from these. And you say, okay, this is the typing. I like the color and price. And that's the same here and there. You're not going to be able to get rid of that because that's the message the person wants to send. But Gmail has to do a whole bunch more stuff. It has to get the to list. It has to put a subject line because you don't want to send something without a subject line because a lot of spam filters throw those away. And so you get to see why is this so much better. And then you can either fix this one, if that's appropriate, or design something that's even better than both. So this visualization, this being able to compare things, is very, very useful. Is there a fast way to upload additional pictures to an existing design? Yes. All you have to do is put them in another folder. So if I go back into like this, so if I had another folder, I could just, I'll do the horrible thing. I'll put all the wet paint images in the Gmail. Whoop, there they are. Okay, so yes, but now I'm going to undo because that was a silly thing to do. Okay. Okay, I do want people to get out of here on time, but there's a couple of really important things. How do I convey using the scroll wheel on the mouse? Unfortunately, we can't do that. We have to scroll with clicking or tabbing at this point. There's actually a forum post about that, an old forum post that I was going to put up on the WordPress site, and I could make that the first one that I put up. It'll be there in a day or two. But unfortunately, right now we can't do that. Okay. All right. So let's get to the next. Let's get to the place that's really important. Okay. So the next couple of slides are that's bizarre. I thought there was a slide on this. These papers are, might be very useful for you if you're a practitioner. And they are available on the WordPress site. They're linked. So let me get back to that and I'll show you where they are. No. CogTool.com. Publications. And so all these publications are here, and so they're by year. And this is a 2010 Bellamy, John Cogan, and a 2012. Okay, so 2010, you can look through here, find this one. This is the Bellamy. This guy. No, not that one. That was 2010. Huh. Now I'm so sorry. This site is very new. It's on top of where I have to be. Where's my find? Oh, next. Yeah, this one. Deploying CogTool, integrating quantitative usability requirement assessment into real-world software development. What we do in that paper is we give 5 examples of how we use this at IBM. One was to prove that we had improved the interface to get the rest of our money, because the contract was written that if you don't improve productivity by 10 times, you don't get the last increment of money. And so we detailed some of those analyses we did. 2 others were showing how having these analyses really helped communication. That both within the product team, like the product team for a long time had decided that they knew there was a problem, but we now had a customer saying this is a problem. Your system is inefficient compared to your competitors. We might leave you. And the UX person did the analyses that we use in CogTool, went to the product team and said, look, not only is this long-standing thing that we didn't, it was a single sign-on thing. The problem was that you had to sign in again, and they knew that. They had to fix that. But there were also some other actions that they had to fix to be as good as their competitor. And so the communication within the product team was very crisp, and they could stop arguing. And also one of the examples was they actually took these analyses back out to the customer and said, you're right, we are not as good as our competitors, but this is what we have to fix to be that good. And the customer understood these timelines. There was another one about 2 groups arguing as to whether the new UI was making things slow versus the new back end. And you can do the CogTool analyses that can show, you do it once with a realistic system response time, and once, as I said before, removing all system response time. If you remove all system response time, then you have a pure comparison between the old UI and the new UI. And so if the new UI is longer, then you know you have to get the user experience people to fix it. If the new UI is faster when there's no system response time, then you know you have to get the back-end people to fix it. So that was a case where the CogTool models helped assign appropriate people. Project managers love these things. They love things that stop arguing. They love things that help them assign people correctly. They love these things. The last one was kind of the original intention of using CogTool, which was assessing design ideas. there were 8 different ways to do the same thing within IBM products, because IBM tends to buy a lot of companies, and so they come in with all different ways to do the same thing, and they wanted to unify all these into one way, but they wanted to make sure the one way was better than all the others. And they did that analysis within a day, doing 9 different CogTool models. So that's the sort of thing that I highly recommend those 2 papers. The second one is about how do you do this when you're not doing it all yourself, but you're doing it with some people are doing parts of the modeling and some people are doing other parts of the modeling, and how we have to coordinate to do that. So there was a question of, in the thing, do you recommend going through any particular publication for doing a comparative analysis? Yes, I do recommend kind of understanding these 5 cases, but the other one was earlier when I showed you the design ideas. I'm getting back to it. This one. This paper is John 2011. And your notes have the actual references of these, not just the name. And this one is using predictive human performance models to inspire and support UI design recommendations. And that was comparing 2 existing products to make a better one. Okay. Go back down. Hey, that was a good guess. Okay. We have shown in several research projects that we can get good predictions on mobile phones as well. This is not surprising, as long as you're doing tapping. And so these were on Palm Pilots. We got good recommendations. Cell phones, now these were actually kind of old cell phones, but we got very good predictions on the types of cell phones where mostly you're tapping. Slightly less good on iPhones, probably because we do need some new motor operators. And we could discuss how to do other operators. There are other research projects that we're going to run out of time. So I think you're probably less interested in these because they're not as well validated as the others. So let's not go into those. Though someone did ask about novice behavior. So I'm just going to skip to that for a second. We do have CogTool Explorer. And instead of demonstrating a task and getting a prediction of skilled performance, you just type in a goal where we were typing in the name of the task and tell it to go. There is a video of that used to live on the old website. I need to get it up into like YouTube. But the paper you can read about that, let me tell you what it does. What it does is it has an eye, it has hands, it starts looking around the screen, it knows what its goal is because you typed it in, you told it what it is. It looks at the first widget that's nearest to where it's looking, and it evaluates whether the label on that widget is relevant to its goal. It's got a lot of math underneath to decide whether it should keep looking, whether it should click on the best thing so far, or whether it should hit the back button. And so, like in this case, it would look, finally decide to choose the best link so far, but it's not this one, it's this one back here. So it goes back and clicks. With that model, we have matched data very well. This is a different type of model, the blue one. What we care about are these, the people are in the maroon, CogTool Explorer is in the tan. We're doing really good there. And here, in a test of 36 tasks, we identified 93% of the tasks that were easy for people, meaning that more than 95% of the people finished them within 3 minutes. And we identified 93% of the hard ones, which means people failed within 3 minutes. So this can help you focus design effort. Don't fix the, if it ain't broke, don't fix it. Okay, only concentrate on the ones that don't work. This, again, is a research project. It is a PhD thesis, so you can read every gory detail. And the code is actually in your CogTool, and it's in the source code. Okay. So I do want to say that I hope that doing CogTool for Keystroke-Level model is easy for you now. Certainly easier than doing the Keystroke-Level model the way Cardinal and Newell did it, and I hope you have some confidence that with these materials you could go back and figure out how to do your own system. And again, you can post things on that blog. Just post a comment anywhere, and I'll get it, and I'll discuss things with you. And let me go to the more general question here. More general question regarding GOMS. Can this modeling be used for heuristic evaluation? So heuristic evaluations are things that human usability people do. You can certainly use the storyboard that you make in CogTool and give people the storyboard and say you do a heuristic evaluation on this. But CogTool itself does not do heuristic evaluation. If you wanted to say more about that question. In fact, why don't we go on audio for anybody who wants to ask a question now for these last 10 minutes that we have. And cognitive walkthroughs. Well, so actually the CogTool Explorer is an automated cognitive walkthrough. CogTool Explorer, we worked with Marilyn Blackman, who's the cognitive walkthrough person left at University of Colorado, Boulder, and it's her tasks that she did with cognitive walkthrough that we're doing on as validation. So CogTool Explorer is an automated cognitive walkthrough. Anybody else have a question? You can go off mute and do things verbally if you do. Oh, Shannon, are we done?
Yeah, that was great. My group here really enjoyed it, and I'm guessing everyone on the call. It's really great going through those examples, and but we, at least here, don't have any more questions.
Okay, and I do want to thank you all for bearing with me this first time I've done this without having people in the room. Some of the challenges were not being able to see the puzzled looks on your faces, but I think the chat worked pretty well for that. So thanks very, very much. And please do postings to questions on that cogtool.com, and I will answer them. Put them anywhere. Right now, I haven't figured out how people can put things there, so just put them anywhere, any comment anywhere, and I will get notified of it, and I will answer it and all. Because WordPress is a blog, so I'm supposed to be initiating things, I think, but if you just put a comment anywhere, I will see it and we'll elevate it up to something that people can find. Okay, thank you all so much. And Shannon, you are going to make this video available eventually, right? It's going to take a while to process and stuff, but great.
We'll probably be putting it onto YouTube and having that link hosted on, or not hosted, but accessible on the UXPA site.
Okay, great. Thanks. Okay. Good. Thanks a lot. And goodbye, I guess.
Goodbye.
Bye. Thank you.
Oh, and Lyle, we were going to do something offline. Do you want to just stay on here and everybody else go off?